So here I am solving this question by using the above theorem. So here the vector is given, show that this is the vector given y square z cube cos of x minus 4x cube z dx plus 2z 3y sin x dy plus 3y square z square sin x minus x4 dz is an exact differential of the scalar point function phi and find phi. So what we have to do is, first we have to check whether del cross a is equals to 0, and in the next step we have to find the value of the phi. So for this is the a vector given, I find the del cross a. So here is the del cross a. When you solve this, I got this result that it is always equals to 0. So in the next step, by using the theorem that according to the theorem, a1 here you can say a1 dx plus a2 dy plus a3 dz, that is equals to d phi. So that means this a vector, this whole term is equals to d phi, like this term. And in the next step, multiplying dx with whole this term, so I separate this term like y square z cube cos x dx. Then in the next step, 2 z cube y sin x dy, then 3 y square z square sin x dz here in the first you can say in the first three terms. And in the next step I write minus 4 of x cube z dx minus x4 dz here. So this is basically the you can say the derivative. So this whole term is the basically the derivation of this function, that dy square z cube sin x minus d x4z. If we take the derivative of this step, I got these values, and if I take the derivative of this function, I got these values, these three values. So this whole result, that is equals to d phi. So that means phi integrating both sides, so I got this result that phi, that is equals to y square z cube sin of x minus x4z plus some constant. So here we find the value of the phi, and in the first step we check that whether the function is exact differential. So I find del cross a, that is equals to 0, and here this is the value of the phi.